Alright, this example we're going to now look at how lenses work. You'll see some of the similarities between lenses and mirrors, but there are also a few little differences, and we'll address those as we go through each one of these lens examples. In this case, we have an object 3 centimeters high, 15 centimeters from a convex lens with a 6 centimeter focal length. Complete the chart using a ray diagram and using the formulas. First thing we're going to do, draw the lens, draw the focal points, draw the object, all to scale. So the object's 3 centimeters high and 15 centimeters away from the lens, 15 spaces, 3 high. The focal points I draw on both sides. That's a little different than mirrors. Focal point 6 centimeters from the lens on both sides. We have to remember that mirrors use reflection, reflects off the mirror, whereas lenses use refraction. It bends light as it passes through. The lens will allow the light to pass through, so we will get images on the other side. First thing we do is start like the same as before, draw that parallel to the tip of the object. Now instead of it reflecting back through the focal point, this thing will bend through the focal point on the other side. It's a little bit different than mirrors. The second one that I always draw is right through the vertex of the lens because it'll pass through undeflected. Those are the two I usually draw. That's enough to draw your image there. This is a real image on the other side. It's inverted and it is smaller than the original object. We'll label that in a few minutes. If you want to draw that third ray just for checking, draw it through the focal point. Then when it hits the lens, it'll be refracted parallel. And notice it's about the same point as the other two. So what we can do is now list the characteristics. It's an inverted image, it's smaller so it's diminished, and it is real on the other side of the lens. It's a real object. Little different than mirrors. Behind the mirror we always had virtual images. But remember with lenses, the light actually passes through the lens. It gets bent as it passes through. So the ray diagrams, even though they use similar properties, do have a little bit different as you're allowing the light to pass through. First thing you're going to have to remember and look for when you do these questions at the end of the unit, am I dealing with a mirror or am I dealing with a lens? And then draw your ray diagrams appropriately. Now if we were to label those numbers, that image is 1, 2, 3, 4, 5, 6, 7, 8, 9, about 9.8 centimeters away, and it's about just under 3 centimeters negative because it is lower than the principal axis. So let's label that on our diagram. The image distance, I'd say about 9.8 centimeters. Height of the object, about negative 1.9 centimeters. List everything we know. We know the height of the object, 3.0 centimeters. We know the distance of the object, 15 centimeters. We know the focal length in this question, 6 centimeters. What we're going to find, distance of the image algebraically, height of the image, and the magnification of the lens. Use the same formula. 1 over f equals 1 over distance of the image plus 1 over distance of the object. Again, manipulate for the image. So it'll be 1 over f minus 1 over distance of the object. Put your numbers in. 1 over 6 centimeters minus 1 over 15 centimeters. Again, do the calculation, then invert it. So 1 divided by 6 minus 1 divided by 15. Reciprocal should give you 10 centimeters as the distance for the image. We were pretty close. We had 9.8. Find the height using the magnification formula. HI over HO equals negative DI over DO. We're going to manipulate for the height of the object. It's negative DI HO over DO. Same formulas that we used back with mirrors. Just got to watch our signs. So it'll be negative times 10 centimeters times the height of the object, which was 3 centimeters, divided by the distance on the object, 15 centimeters. Now, since this thing was inverted, we should end up with a negative height, and we do. So you get 30 divided by 15 as negative 2.0 centimeters. And again, we're pretty close from our graphical answer. Now do our magnification. Magnification HI over HO. Let's use the graphical numbers first. 1.9 over 3. So 1.9 divided by 3 gives us 0.63 times. Should be a number less than 1 because it is smaller. And then do our algebraic calculation. HI over HO. Algebraically, we've got 2.0 over 3, and you should get 0.67 times. Again, fairly close with our ray diagrams in comparison to our actual calculated answers. There is advantages to understanding the ray diagram and being able to do an approximation. There is an advantage to do this algebraically. You should get used to both. You will be expected to do both on the exams. Again, get familiar with the sign convention for mirrors and lenses. There are a few things that are a little bit different between the two. So very first thing you do when you read the question, am I dealing with a mirror or am I dealing with a lens? And then apply the appropriate numbers and signs from there.